Hello again, this is Mr. Wyrick, and today we'll be talking about lesson 1.5. This is some more stuff to do with angle measurement and specifically the relationship between different types of angles. Now there's lots of vocabulary that you're going to need to define and make sure you kind of understand before you come to class to work on your homework. So I'm going to need you to do adjacent angles, a linear pair, vertical angles, complementary angles, supplementary angles, and perpendicular lines. Okay? Now, what we're going to do is talk about these and what they mean about the different angles. So if they're adjacent angles, this is one of the easiest things to do. I draw this. The adjacent angles are the ones like this pair here, or this pair here marked with a double line, or this pair marked with a triple line here. Any angles that are, side by side, those are adjacent. If you think of in the parking lot, there are two cars that are adjacent to you on either side. That's what you need to think of as adjacent. It's to the left or to the right, looking around where those lines cross, those angles are going to be next to each other. Now, some adjacent angles have some special relationships depending on what's happening. Most of them, though, you can definitely just classify as adjacent angles. The next thing that we're going to talk about is a linear pair of angles. And a linear pair are ones that fall on a straight line. So if I have a straight line coming across and one like this, these two here are a linear pair. They are going to add up to 180 degrees because they both have this line as part of the angle. Now it gets a little tricky because if I extend this line through, I've got angle 1 and angle 2 that are a linear pair. Angle 2 and angle 3 are a linear pair. Angle 3 and angle 4 are a linear pair. And angle 1 and angle 4 are a linear pair. So it's all about looking at where they are. If I start adding more angles in here, it stops being a linear pair because we've got 1, 2, 3, 4 different angles that have to come through there. But as long as there are just two, it's a linear pair. Pair, of course, referring to two. When we start talking about vertical angles, I like to go ahead and draw the V, and then I draw an upside down V. When I have a vertical angle, it's one on top of the other like this, or one right next to the other like this. Anytime that you have two lines that are coming through, and only two lines, you create vertical angles. Those vertical angles are, by their very nature, congruent. This is going to be very important when we get into proofs later on. Vertical angles are congruent. Complementary angles, your next one that's on here, again, you're going to write down the definitions. I'm going to demonstrate a little bit. If we have a 90-degree angle and then we take that and cut it, those two angles are complementary. Complementary angles specifically add up to 90 degrees. Now don't get that confused because you'll be using that definition later as well as the definition of supplementary angles. Supplementary angles add up to 180 degrees. Now, here's the tricky part about complementary, supplementary. You may be thinking, well, that supplementary angle, 180 degrees, it's obviously just a linear pair. But if I give you a graph that's like this, and we have angle A, angle B, and angle C, the three of those together are supplementary. So you have to watch out for how it's defined in the problem and how they refer to it. The last thing that I want to talk to you about is perpendicular lines. If you don't already remember this from Algebra 1, perpendicular lines are going to be pretty important because perpendicular lines form 90-degree right angles. Okay? If you have two right angles, obviously they're supplementary. If you cut the 90-degree angle up, it's complementary again. Perpendicular lines are very specifically, and if it doesn't include the definition in your book, I want you to add this in. If you have perpendicular lines, they have opposite reciprocal slopes. Okay? So if we have to do this on a Cartesian coordinate, on a graph where we've got our grid, if we have a line that has a slope of 2, the line that's going to form the perpendicular angle to that is at a -1/2. Now it can be anywhere on the y-intercept in that. The important part is the slopes. If they are opposite reciprocal, so if I go from 2, which we can treat as 2/1, to a negative, that makes it opposite, and then reciprocal, 1/2, that means I've got perpendicular lines. They're going to form a 90-degree angle. So if I've got 3/4, it's a -4/3. If I've got 1/8, it's a -8. If I've got -7/5, it's a +5/7. So I flip it over, I make that reciprocal, and I change the sign from a negative to a positive, or from a positive to a negative. That'll give me those perpendicular lines, that 90-degree angle. Most of the proofs or flow charts that we're going to look at this year, where you have to try to come to a certain conclusion, you will be dealing with these different classifications of angles. So don't write these down and forget all about them. Make sure you refer to them again and again until you know them. Linear pair, vertical, complementary, supplementary, and then those perpendicular lines. Make sure you don't forget the algebra applications of those as well. Understand, if they say complementary, we're going to be adding up to 90 degrees. If they say supplementary, we are going to add up to 180 degrees.